Greetings, this is Anthony Dick giving you the third example set for 1.6 absolute value inequalities and equations. Now, where we left off, we were solving absolute value inequalities, and these are just two that involve some fractions. You need to be comfortable with fractions, so don't let them fear you, but the process is still the same. We're going to treat these like equations, so I'm thinking of this one like 4x plus 1 all over 2 is equal to 4. And then we make two separate equations. We make the equation setting equal to the negative number, and we make the equation set equal to the positive number. And I'm going to solve each of those. Now, with the fractions, the way you clear fractions is you multiply by the denominator, pure and simple. So I'm actually going to do that here on both equations. So you can see you're doing the very same steps in each one. So here you'll get 4x plus 1 equals negative 4 times 2 is negative 8. And then I'm going to subtract the 1 from each side. I get 4x equals negative 9. And I divide by 4. And I get x equals negative 9/4. Cool. Now here, 2 cancels. I'm multiplying. I get 4x plus 1 equals 8. I'm going to subtract 1 from each side. And again, it gets a little tedious sometimes because you're doing the same thing twice. But because the left side is different, the answers are different. X equals 7/4. So I have on my graph negative 9/4 and 7/4. Okay? And infinity and negative infinity. And this is a greater than. So it's an open circle because it's not equal to. And since it's greater than, we're looking at the tails. So there's my graph of my solutions. My solutions themselves in Set Builder, we'll set up x such that, and we go x is less than negative 9/4, or x is greater than 7/4. I hope you've noticed that whenever we're doing these two-sided inequalities, you always have x is less than a number, x is greater than a number, and there's an or in between. In interval notation, you always have negative infinity to the lower number, which in this case is negative 9/4, with a parenthesis or a bracket, depending on what the sign is. This one was not equal to, so it has a parenthesis. Parenthesis, and then you have the higher number to infinity. This almost becomes a fill in the blank that if it's a greater than or a less than, you can predict what I'm going to have. Let me give you an example with this next problem. Okay, 1/3 times the absolute value of x plus 2 is less than or equal to 4. So I'm going to divide by 1/3 or multiply by 3. It's the same thing. My mind sees that as multiplication, so I'm going to divide. X plus 2 is less than or equal to 12. Okay? Now, at this point, you start to think, what's my solution going to look like? This is where you can think ahead. This is a less than. In fact, it's a less than or equal to solution. So that tells you it's going to be brackets in your inequality notation. In your interval notation. And it's going to be an in-between solution where this was two ends. This is going to be something in between a value here and a value here. You're going to have two numbers, and you'll have the in-betweens. I just got to figure out these two numbers. In Set Builder notation, x such that it's going to be x is in between, and I just got to come up with these two numbers. Really, guys, when it's a greater than, you're just finding these two numbers. When it's a less than, you're just finding these two numbers, and you're filling in the blanks. These are very, very predictable. So once I have this isolated, I'm going to solve this equation. Oh, actually, I'm treating it like an equation, right? So equals, and x plus 2 equals negative 12, and x plus 2 equals positive 12. And I will subtract 2 from each side, and I get x equals negative 14 here. I'll subtract 2 from here, and I get x equals 10. There's my numbers, negative 14 and 10. And I can fill these each in on all of my solution sets. Okay? Whenever you have a less than, once you've isolated it, wait till you've isolated it to make the judgment. Once you have a less than, you know that this is what your solution is going to look like. Once you have a greater than, and again, wait till you isolate it, you know your solutions are going to look like this. Last thing is just a little bit instruction on the intervals. Here is a graph. Name all the ways to write the intervals marked on the number line below. Well, this is an opposite end, so it's a lot like these up above. So if I'm going to do it in set builder notation, I started off x such that. Now I need to describe this one. Well, this is -3 or smaller, so that's x is less than or equal to, because it's a solid dot, -3. And since it's two things, so I can have numbers here or over here, I have to describe this upper bound. X is, now this is an open dot, so it's not equal to, but it's bigger, so greater than 4. In integral notation, I have start and stop. So this starts all the way down at -infinity, and it goes to -3, which have a bracket on it because it is a solid dot. Union, this has an open circle, so it's parentheses, 4 all the way up to infinity. And there's the 3 ways I can represent that particular statement. Okay, I guess I could relate them verbally, that this is all numbers less than or equal to -3, or all numbers bigger than 4. I could do that. Okay, that concludes the examples for 1.6. Go ahead and get some practice work on there. Thank you.